I think I've finally, with Montana's help, finally found where the extra drop boxes were. That's annoying. But the other thing I figured out yesterday, none of the videos for the last 6 have shown up in Brightspace. So that's another project to work on. So literally the videos are here, which would have helped. Some of you could have went back and watched them again, and that would have been good. So hopefully before this day's out, I will have a call with the Dark Space gurus and ask them how to make the Panopto videos show up in the right places. Because the only ones that show up are the ones I forced in there, and I'm not forcing them in there. That shouldn't be a part of the problem. Okay, let's talk a little bit about continuity. Okay, and this problem is kind of cool. So think about it like this. We got this, we got this, we got this, and then we can have some fun with it here. And we're going to do this. And then we're going to come out here. And then we're coming back to here. Okay? So I have point 1, point 2, point 3, point 4. Okay? Let's see here. So we got V1 going in, we got V2 going in, we got V4 going out, and then this one right here, I want to phrase this. I want to phrase this way. So actually this is 0.5. Okay? 0.5 could be in or out, depending on what the situation is. Okay? So remember this. Q in must equal Q out. Okay? All right. Let's put some numbers to this thing. So D1, which is D1, D3. D1 equals D3, which equals 5.5 inches. Okay. D2 equals 3.5 inches. D4 is equal to 3.4 inches. And then D5 will be equal to 3.3 inches. Okay. Velocity 1 will be 3.7 feet per second. And velocity 2 will be 1.7 feet per second. And then the other one they give us is V4, which is equal to 5.5 feet per second. Okay? And what we're interested in is this. Find V3 and V5. And flow okay. We won't get this done, but we'll get started and we'll finish it up on Friday. But this is a good one to start thinking about. So let's just, once you get the numbers down, let's discuss it. If you want to doodle ahead, you're more than welcome. You're going to take me from the challenge. You will actually work this problem out and give me the answer on Friday. Yeah, you will. Are you capable of it? Yes. Each of you are. Right? So we got 2 going in and 1 going in. So we're adding 2 flow rates together. Okay? If you add some together, you get a larger number. Difficult. If the world of math has not changed in the last 3,000 years, we're probably still good. Okay? So we should expect at 3 to have a larger flow rate. Okay? So Q1 and Q2 added together should equal the flow rate at Q3. Yes? Okay. Now, 4 is going out. Okay? So we know the velocity at 4. We know the area at 4. So we know the discharge flow going out of this problem, right? Yep. Cool. Now, if I know the flow rate at Q3, and I know the flow rate at Q4, can I figure out which way 5 is flowing in or out and what the flow rate is, and then therefore figure out the velocity of 5? Go ahead, Dave. You started. Yes. Okay. Now, this is a lovely little problem. This is going to have you all over the place. Okay. So, on a grand scale, who's from New York City? You guys know where you get your water from? You probably should.
I know it's really good water, like we have the best.
Yeah, you have the best in the state. So there are 5 reservoirs in the Catskills that New York. Actually, who owns it? Can't remember. It's not the DEC. It's the equivalent of the DEC for New York City. They run. But believe it or not, it's really strange. The first time I was down there and I saw a New York City cop, I'm thinking, what the hell? It's a little out of their territory. I mean, it's only 90 miles away, but still, it's like, where did they come from? Why are they here? And then I realized they guard the reservoir. Not just the one I'm at most time, but there are 5, okay, in that area. You have the, you'll love me for this, Okeechobee reservoir here. You got something over there at 2, and the Okeechobee is the one around Deposit, New York, so that's why I know that. My daughter really used to go out there and look at it all the time, because it's a great big body of water. And her husband's family lost his property so they could make water for New York City. Don't laugh. My in-laws made a fortune. But we got 2 reservoirs that come in, and then we choke it into some pipes going down to New York City. Okay? And then we got a 5th one that could feed in or it takes out. Okay, so we could be at the point now where either where's the reservoir? It's in North Brooklyn. It's the final destination before it gets filtered. Isn't there a big reservoir there in North Brooklyn, or am I crazy? Ooh, we're gonna look this up. I'm gonna go find all these details first. Anyway, so I could be taking water out of there and then heading to one of the boroughs. Okay, or I could be 4 goes right into Manhattan. Who knows? Okay, but that's how your water system works. Okay, and it sounds stupid. Most municipalities are lucky if they have 1 water tower and it feeds the entire area. But sometimes they don't. They feed multiple areas. Okay, and sometimes there's multiple inputs in it. Make sense? Okay, cool. That's the introduction of that topic. We'll finish it on Friday. And I'll get you some homework so you guys can practice. If you want help with anything, hey, wait. If you need help, okay, we've already talked. Matthias reminded me of something. I didn't say it. You guys are free to come into the office anytime you want. Okay? Don't let my real job confuse you from the job I enjoy doing. So if you need me and I'm in there and I'm not in the meeting, the secretaries will let you in. They'll probably get up. It's okay if Matt comes in and sees you right now. It's like, yes. You know, it's really polite about it. But they'll let you in. If you need help, come ask for it. Don't sit around out in the woods. I don't really run office hours because you saw my schedule. There's no way to really figure out office hours. But I'm there. If you see me in the hallway, or if you want to email me, or what was the other thing Mateus did yesterday? Teams. You guys know that you can actually see my schedule on Teams? So if you go into Teams, and he didn't yesterday, if you go into Teams, because my schedule is in Outlook, you can find an open hole in my calendar. And you can set up a meeting request to meet. Okay? Usually pisses off the secretary because I think they have sole control of my calendar. But I tend to let them do it anyway, because if I do it, it screws up the world. But you can actually put a time in there. Let's say 11 o'clock today, you see that I'm free, you're free, bingo, you're in. Okay. Now the other thing, did you know that you can actually put your calendar into Outlook so you know where you're supposed to be and what you're doing? Okay. Use that tool to your advantage. So like, oh, put all your classes in there on a recurring basis. Okay. And if you haven't done it, it's probably a good thing to start doing. Okay? All right. See you later. Yes, sir.
Where does the B5 come from?
So we're going to figure that out. So
That's the velocity of like point
velocity of 0.5. Yeah. So
I thought it was like
we know the diameter of that pipe,
yeah.
but we don't know whether it's going in or out, and we don't know what the velocity is.
Okay.
So we add these two together. That gives us the Q for 3, and then our diameter is the same as 1. So we can figure out Q1, Q2, and then Q1 plus 2Q equals Q3. Q3, we can figure out the velocity because they gave us, I got the diameter there. But we don't need that. We just need to know what this is. So if we know that this solves here, then we can figure out what that solves for. Okay. It's a little math heavy, but it's one of those engineering problems that you're going to do a lot.